Okay, welcome everyone. I'm David Aboud. Today's webinar will focus on 8 reasons to host your components in Altium 365. Throughout the webinar, I will start some poll questions. If you have any questions, please place them in the Q&A panel. And if there are any issues, send them over in the chat panel. Okay, let's get started. So we're going to start off by talking about the placements of components in the design process. And then we will move on to discuss the traditional methods of component storage and some of the major advantages of those methods. Lastly, we will take a look at the advantages of component storage with Altium 365 and see the platform in action. So in the design flow, we have component selection and creation as the very first steps. This is essentially where the design of any PCB starts. We have the component definition consisting of several models. We have a symbol to show how the component looks on the schematic, a footprint to define how to physically attach and electrically connect a component on a board layout, 3D models to show the real world appearance of components. And this helps us with clearance checks and enclosure fit and alignment. And we also have other models such as SPICE simulation models. There are many different methods for component storage, so we'll discuss the core concepts that are most important. Since there are several types of file-based library, today we're going to focus on the storage of these libraries. First, we have individual local storage. This is your personal library on your personal computer or digital storage. This is generally a schematic or PCB library or an integrated library. Then we have local storage in the company network. These libraries can be organized in a local network or shared drive. This method is generally used for database libraries. But people often pass and store other file-based libraries using the network drive as well. Lastly, we're going to talk about something I'm going to call internet resources. So these are downloadable libraries from places like Octopart, and they're libraries that can be downloaded for use. Let's look at some of the disadvantages of these traditional methods. So local storage provides limited access as you are limited to the device on which the library is stored, right? When stored on a company network, user access is much wider, but it is still limited to the internal team members and requires a VPN for access while working remotely. In both cases, it's necessary to use additional programs and applications for discussion, project coordination, and sending files to manufacturing. In any case, each library requires a level of maintenance to keep libraries in sync across team members. Different people will often create components with a different list of parameters and naming conventions for those parameters. Additionally, these libraries take up a certain amount of space on the host device, especially if we consider an example where users add library files for each individual project. The alternative is a database library for the entire company that contains many components and is often slower to access, and it must be maintained with external software. Unfortunately, no server, computer, or digital storage provides 100% guarantee to prevent data corruption or loss. We'll speak later about how this issue is eliminated with Altium 365. The last major disadvantage we'll discuss is the limited functionality of using local libraries. So there's no way to share component definitions across team members or easily reuse them across designs. If we do reuse components, there's no way to track if a component has been used in other designs. This information is critical for component selection. You can identify good components and keep design costs down by enabling procurement to order larger quantities of the same component, such as common resistors or capacitors. As we go into the component creation process with Altium 365, you'll see how enhancements that enable you to have shared models for components allow you to easily update many components at once. We can now start taking a look at cloud component storage in Altium 365. Altium 365 is a cloud-based infrastructure platform, and access is provided by current Altium subscription plans. There are two current subscription plan levels, Standard and Pro. A workspace is an isolated, secure environment where you can store your component and project data as well as manage your team access and settings. The workspace runs on the Altium 365 platform. Access to a workspace is provided with an Altium standard plan that is included as part of your Altium Designer subscription. This workspace provides secure data storage and reuse of existing components, models, and other design data. You can release data as distinctly separate revisions, essentially tracking design changes over time without overriding any previously released data. We'll talk more about this in the next section. So, accessing the Altium 365 platform with a Pro plan enables additional powerful functionality such as component templates, lifecycles, roles, and more. Now that we have an understanding of the Altium 365 platform and the workspace, we can take a look at the advantages of cloud storage. All components are stored in the same location with convenient separation by component type, enabling organized search and filtering capabilities. You can sort by parameters to find similar components and easily compare them to make placement decisions. Any existing libraries can be migrated into the workspace so that every project and every user is using the same component definitions. You're also able to see where all components have been used across all projects in your workspace once placed. When migrating an existing library, the system will check for the component type by looking at the parameter text. If a component type is not automatically defined, then the system will inform you about it before adding the component to Altium 365. When creating a new component, there is also validation of parameters and models. Templates also provide standardization of included parameters and their names to maintain consistency across all component types. It's also very easy to create new components. While creating a new component in the Altium 365 environment, you can acquire component data from the Octoparse database where thousands of components are already created and ready to use. Information includes models, parameters, and supplier information that can be easily edited to suit your needs. You can also clone a component to create a similar component by reusing the parameters and models and making modifications to the required fields. One of the most convenient aspects of Altium 365 is that it provides access from anywhere with your Altium Live credentials. Once you are connected, you can use all components for your projects without the need to download any files. You also have the convenience of built-in version control without the need to set up anything. All component changes are tracked, so you can see when and why it was changed. Symbols, footprints, and other component aspects can be reverted to previous versions, so you never lose any of your work or accidentally overwrite a component. Whenever a component is modified, the revision status indicates that it is out of date. You can find the revision status in the component properties and in the active BOM document. You can quickly update an out-of-date component to the latest revision with a click of the Update button in the Properties panel. Using Active BOM, you can also update all out-of-date components at once. Lastly, you can request a team member to create a new component. This format is especially convenient when the team has a separate member that maintains the library and creates new components. You can create a request from both Altium Designer and through the web browser. Let's move on to the demonstration. I've already activated my empty workspace. You can activate an empty workspace with no components or one with sample data, including a multi-board drone project, almost 700 components from the Octopart Common Parts library in conjunction with Seed Studio, templates, and other materials to help you get started immediately. We will start with adding components to this workspace. We need to start by migrating an existing file-based library with the library Migrator. We go to File, Library Migrator. Note that the library Migrator will only show up in situations where it sees libraries to migrate. If you don't see it, switch to a different document type or close all of your active documents. Now we add any library we want to place in the workspace. I recommend to separate this migration by library type or by project, depending on how you have split up your libraries. You can become easily confused if you try to migrate different library information at the same time. We will look at migrating an integrated, schematic, and PCB library to see the differences. After analysis of the library Migrator window displays the existing library structure, the library structure for your workspace, and all the components that will be included in it. Notice that the component names are not very informative. In order to correct them, we can select other parameters to identify the component name. I will navigate to the Properties panel and select the comment parameter. We see that the names have changed and they are more informative than before. However, not all of them have become meaningful, so it's important to do some cleanup of your library before migration. You can always do the cleanup after migration, so don't worry too much about it. In the Properties panel, you can also configure the part choice mapping and migration checks. For each migration check, you can set the status fatal error, warning, or no report. I'm not going to change the default settings, but we will quickly look at the advanced settings as well. The advanced section is used for configuring the component and revision naming schemes for the different sections of each component. The important thing to note here is the duplicates detection field. You can select a parameter for the library migrator to check to prevent the migration of duplicate components. This is really important when migrating components from multiple sources. Let's prepare for migration with the Validate button. The validation shows several warnings in the Messages panel. Mainly the warnings are for components that have not been included in any category. This means the component type has not been defined. These are not critical errors and we can move on to migration. Click the Migrate button. The system warns you again about the errors. We can confirm and start the migration process. Note, the larger the library, the longer the migration process takes. All transferred components are immediately displayed in the Components panel and are available for immediate use. We receive notification about successful migration and see a specific number of transferred components and models. Next, we proceed with a footprint library. The library is analyzed as before, and the resulting structure is much simpler because the library consists of only footprint models. We'll skip the validation this time and go straight to migration. Once again, we receive a notification. In this case, the number of components will not change because only models were transferred. We will now close the footprint library and continue with the schematic symbols library. During the library migration, full components will be created and added to the final library. When components are migrated, a template is created from the library parameters. We receive a notification with the number of transferred components and models, and we can now close the library migrator window. We see that the new components have been successfully added, and we can start discussing using these components. First of all, we will create a new component. We go to File, New Component. In the opened window, start typing the name of a component. The options update as you type. When you select a name, all of the information for that component will be downloaded from the Octopart database, including parameters, models, part choice lists, and more. Note that all of this information is there to help you. If you'd like to use your own parameters, models, or other information, you can make changes as you see fit. Save locally and see that attached documents and models are displayed in the projects panel. Go to File, Save to Server. Component validation is then performed. No errors are found, so we can release the component and enter any comments to note changes for this component revision. All right, initial creation. After saving, you can check the created component in the Components panel. Now let's try some unique functions that appear when working with our Altium 365 library. First, I will do a component search and then clone a component. You can search by component type from the dropdown. We will further narrow our component choices with the search bar and then apply some filters. Note that even if you do not have access to the internet, you can still use components from Altium 365 as they are cached locally. The next time you log in, all of the information will be updated. Okay, so now I right-click, Operations, Clone, or Control-D for short. In this example, let's fill out the component data ourselves and modify the data that differs from the original component. You can decline proposed data from the Octopart database and select to use only the name. I'd like to highlight that this cloning function is incredibly useful when creating similar elements, such as resistors and capacitors. It will make things much easier for anyone who works with the library. Let's take a deeper look at component validation that occurs when creating a component in Altium 365. We'll delete the description, which is one of the required component parameters. We save the changes locally and try to save the changes to the server. The system informs us that the component was created with an error and offers either to continue or to stop sending it to the server. We will stop and correct the error and try to save the changes to the server again. The process of saving is very quick, and we can already find the new component in the library. Next, we will look at another unique method of component creation. We can use the Manufacturer Part Search panel to download ready-to-use components from the Octopart database. In the Manufacturer Part Search panel, select the component type that you are looking for, or search by name for the component you want, and filter by parameters. A green icon in the component row means that it already has ready-made models. In general, at this point, all actions to create a component are complete because the name and the description of the component are already given, the parameters are filled, and models are attached. We can right-click and select Acquire to open the component editor and release it to the server. If I want, at this point, I can make changes to any of the information. Now I want to show you how a component revision check works and how to check revision status of the components used. Let's drag a component onto the schematic sheet and make some changes. I will add a part choice entry to the component. Part choices contain current information about the component stock, the component availability from manufacturers, and information about the price directly from global suppliers. Defining a part choice on the library level allows you to reuse that part choice across projects. You can modify the part choices on the project level in an active BOM document. After saving the changes, I will check the properties of this component. Out of date indicates that the revision of this component is outdated and should be updated. Here in the properties panel, I click the update button and see that the revision is updated. All parameters, models, and other component information are synchronized with the latest revision, so we never go out to manufacturing with a wrong footprint or other component information. You're also able to see the revision status in an active BOM document and do a batch update of all of those out-of-date components. Lastly, we'll take a look at the part request for component creation. A request to create a component can be created either from Altium Designer or from a workspace in a web browser. Here I am connected to the workspace through my browser. I am going to create a new request. Mandatory fields are marked with exclamation mark icons. This is the name of the manufacturer and the part number of the component. The other fields are completed if necessary and if you have sufficient information. You can specify the required by date and the email of the person who will create the component. I can also select the component type and add a datasheet file. I can change the status of the component in the future to executed, closed, or rejected.